What's up everybody guys, welcome back to Myanmarin tutorial. It's continuation of this video, so if you are interested in scanning and capturing the object or scenes for the Gaussian splatting, I recommend to watch that. In this video, I'm gonna show you how to create a VFX with Gaussian splatting, which is really cool. This is a game changer, and also you can make your artwork or visuals with it. Okay, let's get started. So I'm gonna make the new level. So I'm gonna click on the new level, and I'm gonna click on the basic and create it. And I'm gonna save it in my maps folder, and I'm gonna call it the GS VFX. So first of all, I'm gonna change the parameter of the directional light. So I'm gonna change it for I'm gonna change it to 21 for Y rotation. For Z, I'm gonna change it to 43, so minus 40. And the intensity is 4. Okay, next one is potential hyperbole. The fog density is 0.05. And I'm gonna change the fog intensity color, this one. And I'm gonna change the sky atmosphere as well. So this one is 0.025. Okay, so and I'm gonna delete this one, and also I'm gonna delete this one. And next we need to download the PLI file. I already pasted the link in the description, so let's download that. And then you need to extract as well, and probably you can get this one. And I'm gonna drag and drop to the UnrealEngine content folder, and then I'm gonna save it all. And I'm gonna use this shuttle dynamic. So I'm gonna drop to the viewport, and I'm gonna change the location to 000. And you can see this is a shuttle that I captured. The shuttle is in French. Okay, it's Castle Montreal. Yeah. To make the VFX, there is something you need to know about it. So Gaussian splatting in Unreal Engine 5, the special .pli files we use are made with something called Niagara. It's super cool in Unreal that lets you make all kind of the visual effects. Now, if you want to make your own unique effects like what I'm gonna make, you can change modules in Niagara. And I'm gonna show you the way how we can customize the default Niagara. And if you see the Luma Energy C0, so you can see the Niagara system asset. This is a Niagara that composed this kind of the visual for Gaussian splatting. So to customize this one, we need to duplicate this one. So to be able to come back original one, I'm gonna copy it and duplicate. So I'm gonna click on the this one, and I'm gonna copy, and I'm gonna make the new folder. I'm gonna call it FX, and I'm gonna paste it here, and I'm gonna change the name, and it's Luma AI custom. So now we can keep original one safe. So I'm gonna open up. So if you see the this Luma scene emitter, there are a bunch of the like a custom module which is mostly written by HSL. So I think deep diving to the each module is pretty difficult for this tutorial. So I'm gonna show you the quick solution to make own Niagara system. So speaking of the emitter update, they have a spawn particles in the grid. So there is a limitation of it. So you can't use the spawn rate or spawn burst instantaneous. We can't increase the number of the particle. If you do that, like you will get the error in the viewport. So I don't recommend to do that. So we need to keep it stay in this one. So and then we can add the and I'm gonna add the curl noise pause, which everyone like it. So and I'm gonna click the fix noise, fix issue, and then we can solve the pause and the velocity. So let's see that's what is going on, and I'm gonna compile this one and then save it, and then go back to the GS3FX, and I'm gonna open the GS Shadow Dynamic, and I'm gonna change this one, and I'm gonna change the Niagara to what we made, and then I'm gonna compile save it, and then if you see the this shadow, it's a little bit to change, but and something isn't working. That's because the default one calculates the position every frame. If you go back to the particle update, they calculate the position every frame because it's in a particle update, right? The particle update runs every frame. On the other hand, if we calculate the position at the only beginning, we can handle it freely, right? So I'm gonna move these module. So these I'm gonna move these module, this one, to particle spawn. So first of all, I'm gonna move it up, and this one move it up, and if I compile it and save it, and let's go back to the viewport. Yeah, that's it, right? It's really cool. So you can make the own like a particle Niagara system, and that you can control with the any force like a cow noise or something like that. So now I'm gonna use the my effect, and so first of all I'm gonna change the noise here. So first I'm gonna make the blue, make custom float from blue, and in the blue I'm gonna set blue by float comparison, and then here is I'm gonna the distance between position, and here I'm gonna select the position, but position of the initial particle position, and B I can specify the location, but I want to change the position dynamically, so I'm gonna add the user parameter. So this is position, and I'm gonna call it random position, and I'm gonna drag and drop to here, and the B is 250. So and I'm gonna change the comparison type to less than B. So I can only at the force within the 250, and that's really cool. So and then to for the noise frequency to 20. So I also want to change the color, especially emissive. So I'm gonna add the dynamic material parameter. So and then I'm gonna move it up, and I'm gonna copy this one, and copy it, and back to here, and paste it. So and I'm gonna change the true flow. So I'm gonna add the clamp. I'm gonna add the multiply float, and I'm gonna change the scale by the audio value. So which means I need to add the audio like a parameter. So I'm gonna add the float user parameter, and then I'm gonna call it audio amplitude. So and then I'm gonna drop to here, and then I want to change the color by the velocity as well. So I'm gonna add the dy float, and a is 10, and I'm gonna make vector, make float from vector, and let's go to the parameters, and then if you open the particle attribute, you can find the velocity. So I'm gonna add the velocity here, and I'm gonna change the channel to 1, and the mean is 0, and the max is 50, so we can clamp it. So I want to change the dynamic parameter. So I need to make the own material. So if you back into the editor, just in case I'm gonna compile and save it, I'm gonna back into the editor. So if you click on the Luma, and we can see what material they have. Go down to the here, and yeah, this one material. And I'm gonna click on the content browser, and also we need to copy and duplicate this one. So I'm gonna copy it and go back to the effects, and I'm gonna add the new folder, materials, and I'm gonna dive into it, and I'm gonna paste it, and I'm gonna change the name and Luma dynamic, and I'm gonna open up. So now I'm gonna add the dynamic parameter, and we only use the this parameter one. So I'm now also add the new color. If you click on the left and this type of 3, so we can get the color, and I'm gonna change the color around here, and I'm gonna add the multiply nodes, and then I'm gonna connect it here, and then finally I'm gonna connect it and apply, save it, and then go back to the viewport, and I'm gonna select this one, and I'm gonna apply to the material, and then save it, and then go back to the Niagara. We need to change the position to the initial, because we can't increase the number of the particles, so we need to the particle go back to the basic position. So I'm gonna add the set new existing parameter, and I'm gonna move it up here, and then I'm gonna select the position, and I'm gonna add the lerp position, and A is the position initial, and the second one is position, so normal position, and alpha I'm gonna use the audio amplitude. I'm gonna copy and paste it, and also I'm gonna add this new parameter directly. I'm gonna move it up. So I need to do a same thing for velocity. So velocity, and also I'm gonna add the lerp vector, and A is 0, and second one is go to the parameter and the velocity, and also the alpha is the audio amplitude. So I'm gonna drag and drop to the alpha, and that's it. And compile, save it. To control the effect by audio, I'm gonna drag and drop to the OSC Recieved here. So if you don't have an OSC Recieved blueprint, you need to go back to the other video. This is super like a simple. It takes like a 5 minutes to make that, so you can go back to the video and then come back to this video. So, and then I'm gonna make some like audio reactive system in this blueprint. So I'm gonna open up. So let's go to the event graph, and then first of all, I'm gonna make the new variable. I'm gonna call it BP OSC received, and then type is BP OSC received, not class, received object reference. And the second one is address, type is string. So if you click the BP OSC receive, we can get the OSC received event. So and then I'm gonna drag and drop to the address, and I'm gonna equal exactly, and I'm gonna hook it up to the here, and I'm gonna branch, and I'm gonna connect it to here. So I'm gonna do once, and also I'm gonna flip flop. So flip flop, I mean like if like land A, and next one's land B, and the next one's land A, land B, like flipped. And then so I'm gonna have the new variable. It's random position, and then type is vector, and I'm gonna set the random position here, connected. So I'm gonna split the pin, and I'm gonna have the random float in range. This is for x, and then mean is 100, max is 900. And I'm gonna copy and paste it, and this is for z, z, and mean is 0, max is 200, and I'm gonna connect it to here and here, and the y is 300. Okay, so I want to set the variable or the Niagara parameter. So I'm gonna drag the Luma NGC, and I'm gonna get the copy, and now this is the Niagara particle system, and I'm gonna set the Niagara variable position, and connect it here, and here is random position. So I'm gonna compile. So this is a really hassle. This is a annoying problem. Now we can't compile because Luma Niagara is not the blueprint visible. So which means we need to accessibility in C++, but we can't open the C++ file, not the good way, but we can get around this problem. So I found it, but it's a little bit weird, but we need to do that. This is the only solution we can do that. So I'm gonna delete this one, and I'm gonna get component by class, and I'm gonna Niagara component, and then I'm gonna get copy, and the index is 0, and now we can connect it here, and I'm gonna connect it the position to here, and if I try to compile, we can do that. That's really interesting. Okay, now we need to also at the audio amplitude, so set Niagara variable float, and variable name is audio amplitude, and the value is 1, and I'm gonna delay, and duration is 2, and I'm gonna connect it the reset of the do ones. So I'm gonna organize the node, and I'm gonna organize the node. Okay, cool. So next we gonna make go back to the initial position, the function of the go back to the initial position. So Now I'm gonna use the timeline, and I'm gonna reconnect to play from start, and I'm gonna double click on the timeline, and we can make the own timeline node. And I'm gonna track, and I'm gonna float track, and the length is 1.5 for me, and then I'm gonna add the Q key, and time is 0, and the value is 1, and I'm gonna add the new key here, and time is 1. For me, 1.0, and the value is 2. So okay, length, I'm gonna change the length as 1.2, and go back to this one, and then also I'm gonna copy this one to paste it here, and I'm gonna connect the update, and also I'm gonna connect the Niagara, and the value is new track 0, and then from the finish to the reset, and I want to organize node, and then I'm gonna set the address, default address, so I'm gonna use the key and compile save it, and don't forget to make it public to change in the editor. So I'm gonna compile save. So let's back to the report and save it, and I'm gonna select the OSC Recieved, and address is kick. So let's open the TouchDesigner, and I already created the send the OSC, and especially we can send the low, mid, high, kick, snare, rhythm from the audio. So if you don't have this one, I also created this node in this video, so you can go back to the video and just make this one. So it takes just 2 minutes or 3 minutes. So you can go back and then come back to this. So if you want to change the audio, you can change the audio from here. So as you know, and if you want to use the audio device name, you can use it. Just you need to change this here. So now I already sent the OSC, so I'm gonna go back to the UnrealEngine and compile. So let's open it. Okay, now we can make the this really cool VFX. Ooh, that's really nice. And you can change it to whatever you want, because I just add the car noise, so you can change it whatever you want. But they have some limitation as well. If you have a probably culling problem, so to fix that, if you go back to here, and you can see everything, and then now you can see the all Gaussian splatting. So probably it's not a good idea. So if you have a good solution, please send your solution in this comment and share it for the community. Thanks. Okay, now I'm gonna add the camera, and also I'm gonna add the camera layer. So I'm gonna change the location, the camera layer. X is -60, and Y is -150, and Z is -127, and I'm gonna attach to the camera link, and I'm gonna change the location of the camera, and then so I'm gonna change the rotation like this one, and I'm gonna move up the camera, and then also I'm gonna change the location as well. So I'm gonna change it to the local scale, and I'm gonna probably move it up like here. It's a bit too much. And also I'm gonna change the focal length to 10, and also we can move it up around here. Okay, and now I'm gonna change the path of the camera layout to here, and we can add the new spline point, and we can move it up here, and then I'm gonna save it. I'm gonna go to the open level blueprint, and I'm gonna grab the level blueprint, and I'm gonna drag and drop to camera layer, and also Shinekami back to the window. So I'm gonna get the player controller, and I'm gonna add the set view target with blend, and I'm gonna connect the Shinekami actor to the new view for target, and then move it, and I'm gonna hook it up from the begin play to the set view target with blend, and I'm gonna add the new variable. I'm gonna call it time, and the type is float, and I'm gonna drag it to here and get time, and I'm gonna add the later, and then I'm gonna add the delta second, and I'm gonna add the set time, and I'm gonna set here and connect it. And from the camera layer, we can set the current position on layer. So, and from the time, I'm gonna add the sine radians, and also I'm gonna add the absolute, and then I forgot to make the multiply, and I'm gonna change it the variable value to the 0.1, and then I'm gonna reconnect it. Okay, so now we can connect it here and connect it here. So now compile, save it. So let's go back to the viewport, and then yeah, we can make the this VFX with the Gaussian Splatting. That's really cool. And then so this is a little bit my preference. I want to add the visual effect post process volume, and I'm gonna change the infinite extents, and then what I want to add is the room, and I change the intensity, and then also I want to add the motion blur. So if you go back to where's the motion blur, is the motion blur is here, and in the future amount is around this one. Okay, and then I'm gonna do it again. Okay, they have a broom. Okay, probably if I change the here to 1, probably it's really first. Yeah, it's really first. It's really first, and it's so weird. Okay, you can tweak the parameters as you wish. So, and that's a wrap up, folks. We've taken a deep dive into the creating a custom VFX in Unreal Engine 5 using the Gaussian Splatting and Niagara. We tweaked the emitters and added some cool noise, and made our effect react to the sound, even though there are some limitations. Now it's your turn to get the creative and make something awesome. Don't forget to like, subscribe, and drop your question or creation below the comment section. Stay tuned for more tips and tricks. See you. Bye.